Good day mga kamatics. So next is the second column of term 7y negative r negative 5x plus 8z. So this is what we call the second term or the linear term. Right? Yun yung linear term natin. Okay? Next is the last column. These are just the numbers negative 12, negative 12, sorry, plus 2 and 16. These are the constant, okay, the third term. So question is, what is a quadratic equation? So quadratic equation is what? The question, sir, is going circle. Okay, so quadratic equation is a polynomial equation which is expressed in one variable. A polynomial equation in one variable expressed in the form of ax squared plus bx plus c equal to 0, where a, b, and c are real numbers, right? And a must not be equal to 0. Why is it necessary for a not to be equal to 0? Because if you let a equal to 0, the quadratic term becomes 0. So this is not a quadratic equation anymore. It will be a linear equation. Alright? Moving on. A quadratic equation, ax squared plus bx plus c equal to 0, is a second degree equation. So how are you able to identify if it's a second degree equation? Okay, that is in the red box na. Right? Should have the exponent of 2. Here in number 4, is it a quadratic expression? Yes, it's a quadratic expression. If we equate it to 0, it's a quadratic equation na. Right? But sir, it's lacking the b. So that is why we wrote here, we opted to write here 0m. 0m is the linear term, right? What is the value of a now? A is equal to 1, obviously. So if it's not written in there, that's equal to 1. Coefficient of m squared, which is equal to 1. The b, if you take a look at this expression first, you won't see b. But if you express it like this, you can identify the b. Or if it's not written there, obviously, or automatically, it will be 0. So b is equal to 0. And then the constant is negative 36. Alright? So let's try this following items. Identify which of the following equations are quadratic in the form ax squared plus bx plus c. Okay? So, in the first item, is it a quadratic or not? Yes, it is a quadratic. Why? Because it is in degree 2 and the terms are complete, right? We have the quadratic, we have the linear, we have the constant term. How about the second item? Is it a quadratic? Yes, it's a quadratic. But sir, it's not complete. It's still a quadratic even if it's not complete. A quadratic equation can be considered, an equation can be considered quadratic if it has at least 2 terms, and also at the same time the quadratic term is present since it has the quadratic term, right? How about number 3? Is it a quadratic or not? Of course it's not. Again, I said earlier, quadratic equations is an equation in one variable expressed. Okay, one variable. How about the number 3? How many variables are there? Okay, so it's not a quadratic equation because there are 2 variables involved. How about number 4? Is it a quadratic equation? No, it's not a quadratic equation because It's not a quadratic equation because, alright, because there is no quadratic term and it contains the rational exponent, or this is what we usually have, right? The scaffolds, the problem solving in the first quarter. This is the radical, an example of a radical equation, remember? How about number 5? So number 5, sir, we cannot see or we cannot observe the quadratic term. But if you try to simplify that, you can achieve this equation, x squared minus x minus 2, using the proportion. So x times x, then x plus 2 times 1, right? Then you put it into standard. So what you need to remember with quadratic equation, it is a polynomial equation in one variable, again in one variable, expressed in the form ax squared plus bx plus c equal to 0, where a, b, and c are real numbers such that a must not be equal to 0. Alright, remember that. Why is it necessary for a not to be equal to 0? Because there will be no quadratic term and it will be a linear equation. And equations can still be considered quadratic even if it has at least, or even if it has only 2 terms, as long as it contains the quadratic term ax squared. Okay, so write the following in standard form: ax squared plus bx plus c equal to 0. Identify the quadratic, linear, and the constant term of each equation. Then identify the value of a, b, and c. Okay, so in putting the equation into standard form, we always set the quadratic term as positive. Alright, so yeah, you have to consider the quadratic term must be in positive. Okay, so here you can pause the video before you proceed to the next part of the video and then answer. Okay, so in number 1, let us put it first into quadratic in standard. So right, this is number 1. So the given is actually 9x plus 28 equal to 9x squared, but since 9x squared is already positive, so what we did is we put the other terms to the other side so that the quadratic term remains positive. Alright, and then this is our quadratic term, 9x squared minus 9x minus 28 equal to 0. Quadratic term is 9x squared, linear is negative 9x, and then constant is negative 28. A is equal to 9, b is equal to negative 9, c is equal to negative 28. Let's go to number 2. So the standard form is 7x squared minus 6x minus 20 equal to 0. Quadratic term is 7x squared, linear term is negative 6x. Constant term is negative 20. A is 7, B is negative 6, C is negative 20. So again, always set the quadratic term is positive. And then number 3, right? So x squared minus 3x. Sir, is this a quadratic? It's not complete. Yes, it's quadratic even if it's not complete. So we can identify now the quadratic term, which is x squared, and then the linear term is negative 3x. The constant is 0. So a is equal to 1 and b is negative 3, c is 0. So and 1, obviously there's invisible 1 there. So in number 4, you still have to multiply or distribute the 4, negative 4 actually. So negative 4 times 2, that's negative 8. Negative 4 times x, that's negative 4x. And then if you combine together the like terms, negative 8 and negative 13, that's negative 21. So therefore, the standard form is x squared minus 4x minus 21 equal to 0. And then the quadratic term is x squared, linear is negative 4x, and the constant term is negative 21. Which gives us the a, which is 1, b is negative 4, c is negative 21. Number 5 is still the same with number 4. You still have to multiply the 6, distribute it there inside the parentheses. So 6 times 1, that's 6, and then 6 times negative x is negative 6x plus 2. Just copy the rest of the terms. Now, if you notice, we can combine 6 and 2, right? But what I did here is I didn't combine it yet, and then I take note that the quadratic term, or the one with the exponent of 2, is already positive. So my goal is to put it there lang, and I transfer, or I put the other terms to the other side of the equation, and then change the sign. So 0 is equal to 3x squared plus 6x. Actually, when we move terms, we used a property of equality with that one. So it's what we call the addition property of equality, right? So 3x squared plus 6x minus 17 minus 2 minus 6. So what happened is yung positive 6 becomes negative, and then also the positive 2 becomes negative. So next is we combine the like terms. So if you notice, the numbers here are all negative. So if we combine negatives, we only copy the sign and then add them together. 17 plus 2 plus 6, that's 25. So negative 25. Sir, why is it that this one, the first line, is just equal to this one? So yan, there is a property that proves, or that justifies that one. Okay, so pag binaliktad mo yung equation, equal lang sila. So 3x squared plus 6x minus 25 is equal to 0. Same goes to here. Here in number 1, right? Number 1. So, sir, if we change the parts, or the right side to put it in the left side, and then the left side put it in the right side, are the signs going to change? Do we need to change the sign? No. It is okay to flip the equation as long as you don't middle with the rules, no? So you don't change the signs. Okay? These are equal because we didn't change any. We just put transferred or flipped the equation. So the quadratic term is 3x squared, and then the linear term is 6x. Constant is negative 25. Then a is equal to 3, b is equal to 6, c is negative 25. So always think that quadratic terms must be positive, right? Okay. So you can have the following items, no? And then thanks for watching.